Hey, Analysis 2, this is Allison, Sam, and Steph coming at you with worksheet 7.4. Wow, I can't believe we're already at worksheet 7. So number 4 says if f is integrable and g is integrable on the closed interval a to b, prove their product is also integrable on the closed interval a to b. Let's go ahead and start off with a couple of assumptions, okay? Let's just use a nice blue here. So since we know that f and g are integrable on the closed interval a to b, from the last homework assignment we did, we're going to use two properties, or two results, I should say, two results. The first result is that the sum of two integrable functions is also integrable. And we also can assume that a constant times an integrable function is also integrable. In using property or result number 2, we actually can extend result number 1 to be the difference of two integrable functions is integrable, because if you just let the constant be -1, then this would just be the sum of two integrable functions, but then g is being multiplied by -1, and therefore it's still integrable by results 1 and 2 together. So we're going to go ahead and extend that to the sum and difference of two integrable functions is integrable. And this is from homework 6, and of course we're talking about the closed interval a to b right here. Okay? The next thing we can do is we can let or set our phi of x to be x to the second power. Okay? Now, we don't need to prove x squared is continuous, right? That's very obvious, very clear. And since it is continuous, the result from problem number 1 is going to apply. So we can say from homework 7, so this is technically question 1 from homework 7, we can now assume that f squared and g squared are also integrable. And this is from worksheet 7, the number 1 on this one. So this is also on the closed interval a to b. Okay, so that's what we can assume now. And now we can kind of get things cracking. So let's go ahead and start to piece things together. So we have 3 results here that we're going to need to use. So the next line in this proof, let's go ahead and extend that page. The next line in this proof is going to be that we want to basically lead into our function, our product of f and g. And to do that, we're first going to examine the sum, which we know is integrable, squared, which we know if we square an integrable function, it is also integrable, and the difference, which we know is integrable. And let's make sure that's still going. Okay. And the difference is integrable, and we're going to square it, which is still integrable. So we know that these two pieces together are integrable on the closed interval a to b. Okay. And the next thing we can do is we can use a constant multiple rule. And let's examine this one right here. So I'll just do this. Let's examine this one right here. Let's go ahead and multiply that one by a -1. So we know now if we take f plus g squared, which is integrable, and we minus f minus g squared, which is also integrable, we know if you subtract two integrable functions, you have an integrable function. So we know this whole thing right here is going to be integrable on the closed interval a to b. And the last thing we're going to do is use the constant multiple rule one more time and say, okay, well, if this whole thing is integrable, if I multiply it by a constant, the result must be integrable. So f plus g squared minus f minus g squared is integrable on a to b. Okay? Now, that may have seemed like a really tedious process, but now what we can do is actually examine what we've built. And you're going to see the result is kind of neat. So let's go ahead and examine that. So, oh, no, stop that. Come back here. Thank you. All right, hey, stay there. Thank you. So if we leave the 1/4 out front and we go ahead and expand everything in here, we're going to get f squared plus 2fg plus g squared minus f squared plus 2fg plus g squared. And then, oh, no, this is going to be a minus g squared. Minus g squared. There we go. That's great. And what we know is that this is integrable. Okay, because I haven't done anything but expand. Let's go ahead now and simplify. So we've got f squared minus f squared, g squared minus g squared. So what that implies is that 1/4 times 4fg, if you add the 2 and the 2 together, is integrable. And therefore, 1/4 and the 4 cancel each other out. So f times g must be integrable on a to b. Okay, so that is the conclusion of the proof, and we can actually just, if we wanted to, go like this. I hope that was clear.